Let's use the fundamental theorem of calculus, which says we can find definite integrals with antiderivatives to find the following. We're going to start with an antiderivative problem, and then we'll use this technique to solve an area problem. So if I want to integrate x cubed plus 1 over x squared from 1 to 2, there is no quotient rule for antiderivatives. First thing I'm going to have to do is divide both terms by x squared. X to the third divided by x squared is x, and we can rewrite 1 over x squared as x to the negative 2. Now I can use my power rule, which says I add 1 to the exponent. I get x squared over 2 plus x to the negative 1 over negative 1. Or I can write this as x squared over 2 minus 1 over x. Now to find this definite integral, I have to plug in my bounds of integration. I start by plugging in my upper bound, so I'm going to plug 2 into my antiderivative. That gives me 2 squared over 2 minus 1 over 2. And then I'm going to plug in 1, and I'm going to subtract those values. So 1 squared over 2 minus 1 over 1. That gave me 4 over 2 minus a half, and then we get minus a half plus 1. So 2 minus 1 plus 1 is 2. In the second example, we're going to find the area between the x-axis and the function f of x equals x squared minus 1 from 0 to 2. So I'm going to start by drawing a picture. X squared minus 1 is a parabola that's been shifted down 1 unit. I can find the zeros, or the x-intercepts, by setting this equation equal to 0. X squared minus 1 equals 0 when x squared is 1, or when x is plus or minus 1. So the graph crosses the x-axis at x equals 1. We're finding the area between the x-axis from x equals 0 to x equals 2. That means part of this function is below the x-axis and part is above. I'm going to have to integrate these two sections separately. In other words, I'm going to have to integrate from 0 to 1, and that's going to give me a negative answer. That will give me the negative area. And then I'll integrate from 1 to 2, and that should give me a positive answer. So I integrate x squared minus 1. I get x cubed over 3 minus x. And then I have to plug in my bounds of integration. I plug in 1, I plug in 0, and I subtract. And I was left with negative 2/3. I'm glad my answer was negative because that part of the function was below the x-axis. That tells me the area of that region is 2/3. I do the same thing from 1 to 2, so my antiderivative is still x cubed over 3 minus x. I plug in the 2, I plug in the 1, and I subtract those things. Doing the arithmetic, I end up with 4/3. I'm glad the answer is positive because that part of the function is above the x-axis. Finally, if I want to find the total area of the region shaded in red, I take 2/3 plus 4/3, that's 6/3, or 2. So total area is 2.